Good day, everyone. This is a new online class lecture about thermodynamics class. It was, as we mentioned before, we are in chapter 4, which is related to the processes and the states of the closed system. Maybe I can give you a review on this. Okay. As a review, I want to tell you what is the closed system process. As you know, for the closed systems that we have, we said in thermodynamics, we have open and closed systems. So we are in this chapter talking about closed system processes. Now, for as a review and as to tell you, to summarize what we have in this closed process, we have different processes. Processes that we have we have five processes that we have. The problem is that when they are coming late, I have to stop and then admitting them to our meeting. However, now we said we have five. This is the first one. The first one, I mean by the process or the states that we have. The process, as I mentioned before, is the description of state to state 1 to another state, which is state 2, in the properties that we have. We said in state 1, there are many, or there are at least 3 factors more important to describe the state. The temperature, which is T, the pressure, which is P, and the volume or specific volume, V. Those are mainly the cases that we have, and also we don't forget to have those can be described for any state. So we have for state 1, T1, P1, V1. For state 2, we have T2, P2, V2. Okay? Now, when we are going to, when anything happened to you from state 1 to state 2, it's called a process. This process can be classified majorly into 5 principal processes. The first one is called constant volume, which is volume is constant. That was our first case or our first states. And we, let's say, we described this one in the previous example, in the previous lecture, when what I mean by the constant volume, here's the constant volume. There are the relation between the, this is the constant volume. The relations will be like this. The pressure in state 1 will be specified as P1, and the pressure at state 2 will be specified at P2. But what will be happened from when I'm going from 1 to 2 or back and forth, then there will not have been any change in the volume. So the volume in that state to remain constant. That's called constant volume process. And for the constant volume process, here is mainly the descriptions of the states. So for P1, V1, and T1, those are as I mentioned, those are the main parameters that we have. They have their values. while the m is the mass and r is the gas constant. So this is the real gas relation. So when we are stating that the volume stay constant for this process, so for state 1 and state 2 like these, the relation between the state 1 and state 2, which means the process, is like this. P2 over P1 is like T2 over T1. And this will be the description of the relation between those P1 to, and this is the drawing. This is called thermodynamic relation between those concepts. And we have to also, for this process, we have to describe for the delta U. Delta U is the internal energy change in when I'm going from 1 to 2. You know, when you are going from state 1 to state 2 and increasing the pressure, there will be a change in the what? A change in the internal energy of that gas or in that material. So what will be that one? It will be as much as mass times C sub V times T2 minus T1. And C sub V is called specific heat value for volume related, or when we have volume constant ratio. And there is also delta U, which is also the change of enthalpy, also the mass times Cp T2 minus T1. Now, what is the relation between Cp and Cv? Cv, the relation is that K, we have a constant index, is equal to Cp over Cv. Usually it will be more than 1. That's the key. Okay. Now, what else we have to describe the status of the process is to describe what is the work done. The work done here is while we have is the change in the volume. How much is the volume will be changed? Multiplied by the pressure, the delta P. Now, since we don't have any change in the volume, so there is no work done. There is no any movement. So work done is 0, and heat transfer Q. That usually the Q is equal to what is the work done plus the delta U, the change in internal energy, and plus the work have been done. That's called heat transfer. Heat transfer. Now, since we don't have any work, so the Q is the heat transfer will be as much as the change has been done in the delta U. So all these equations or all these, let's say, the equations that I described, it's all belong to one status, state 1, which is in constant volume states. And also we mentioned that, and we solved an example on this one. So back to, so we have, was the first status. The second one is when we have a constant pressure, isobaric process. Isobaric process describing is when the pressure is constant from state to another state. While we have state 1 and while we have state 2, for any change in those two states, there will be what we call it isobaric process. Now, is there any change? Yes, there is. As we mentioned here, the pressure and the volume, it was like this: P1, P2, and V1 and V2. So V1 equal to V2. That was in the first one. For the isobaric, when we have the change will be like this: pressure and V, P in the P1, case 1, state 1, and P in state 2, they have the same value. We don't have here, so P1 equal to P2 and equal to P constant. So P constant means stay we don't have, but there is a change, V1 and V2. So V will be changed. So here is the difference in this one. The area under the gap is called the work done. So work done here is equal to, and the relations between those parameters for state 2 is this. Like the previous one, P1 V1 is equal to MRT1, P2 V2 MRT2. The change is that we have the pressure is constant from state 1 to state 2. That will be the relation between the temperature and volume. So as much as you have more volume when increased, when we have temperature increased, the volume will be increased. So increasing the temperature, the volume will be increased and the pressure will remain constant. Okay, and what is the internal energy? Absolutely, when we have the change, when there will be a change in the volume, then what happened will be the change in the temperature will increase. The change in delta T will be delta U. And don't forget, in each of those equations, temperature should be in Kelvin. Is the
عفو
Kelvin
صوتي برم بس صوتي نما أم دو دقي آخر لاقى كر واسطة
هيستاهل؟
بلا بلا
ئێستا
لسه
باشە
هي
دوکتۆر ئێستا باشە بەس دوایی نەما
بينما decay temperature, the temperature is in Kelvin. يعني شي Kelvin. يعني when I'm giving, let's say, if the temperature was 20 degrees Celsius. So what will be that in Kelvin? It will be Kelvin equal to 273 plus 20. So it's equal to 293 Kelvin. And don't forget that all these should be in Kelvin. Okay. Next, for the second part, as I mentioned, there will be delta U, M, mass, CV is the specific feed, and we told you that CV, if it's given, it will be based on the material CP and CV from table, usual. When we have a specific material, then we have to change, find it. For example, here, for, sorry, here, like this. This is for air. For air, CP is 1.005. CV, it means 1.005 kilojoules needed to raise the temperature of 1 kilogram of air. Okay, and that's when we have the pressure is constant. When we have the volume is constant, you need 0.718 and kilojoule needed to raise the temperature from for 1 kilogram into 1 degree Kelvin. Okay, now what is the K? K is equal to CP over CV. Now, what is the CP here? The CP is 1.005 divided by 0.718, and there is no unitless. So what will be the answer?
1.39.
1.39.
39.
Exactly about to say 1.4. Okay. And there is another relation between R, CP, and CV. What is the relation? The relation is R is equal, which is the gas rate constant, is equal to CP minus CV. Now, what is the 1.005 minus 1.718? Now here I have to say it's called kilojoule per kilogram per Kelvin. What's that value? It's supposed to be
0.287.
right? 0.287, which is this one. Okay, so this is the relation between R, CP, CV. We need them for our calculation. So this is the basic, and that's for what? For you don't need to remember to memorize. You need to what? You need to sorry. Okay, back to our lecture. Is that all clear? Hello?
Yes,
Yes,
Dr. Clear.
doctor.
Yes, doctor.
Yes, doctor.
Okay.
Yes,
So
doctor.
we back to the second states. Now, what was the first one? Constant volume. Those are the equations of them. And for the second process is here, P1, V1, MRT1, P2, and those are the known values. And here, sometimes you don't need to memorize because I'm done with these equations. It's all, so you just need to use this one. This is all, let's say, derivation of this one. This is what you need. This is what you need. And this is what you need. Okay? No, you don't need to memorize this one. And also we have solved what we call it problem on this one. Now here is what the second thing. The third one. Third one is we have for the first one we say P is constant, right? For the second one we say V constant. Now for the third one we have another case which is called adiabatic. Here's the third process, isothermal process. Now here we have temperature will stay constant. Isothermal, this is the third one. Make it clear. Third one, when we have isothermal. Isothermal process, what that means temperature stay constant. Not the volume, neither the pressure. The temperature means when we have state 1 and when we have state 2, T1 exactly will be equal to exactly T2. No change and nothing be changed. That's the meaning of ISO. ISO means equal, thermal process. And if I want to describe more about this process, here's the third process. The third process, here's the isothermal. Means what? Means temperature stay constant. Okay, So what will be the variable? We have volume, we have the pressure. So the volume and the pressure they will be changed. So automatically when we increase the pressure, what will be happen? When the pressure is here, when you have increasing or decreasing the pressure, the volume will be increased. Why? Because we need the P and V stay constant, the production. The pressure times the volume stay constant. So when we are increasing the pressure, the volume should be less to stay constant. When we increasing the volume, the pressure will be less. So the PV will stay constant. Here's the description of the isothermal. Now, what will be the change in the equation? Yes, there will be a change in the equation because you can see for the case 1 and the case state 2, the temperature here are stay the same. So when we are dividing equation 1 by equation 2, those are being cancelled out. So what left? P2 V2 over P1 V1 equal to 1 means P2 V2 equal to. So P2 here is the most important equation that you need the relation between P2 and V2. P2 V2, this is P1 V1. So this point is process 1, this is process 2. So this is the equation of this one. And also, when we say there is isothermal, means delta U is the change in the internal energy. This will happen while you have a change in the temperature, right? So when we don't have any change, when we say T2 is equal to T1, now this term becomes 0. There is no any change. So there will not be any change in the internal energy. And the same for the enthalpy. Now, what will be the work done? The work done is as we mentioned, is the area under this curve. Is the area under this curve? Here is the work done. That's the work done. It's equal to P times delta V, and we can say here's the equation of the. Here's what you need to know. This is simplified. So we use this equation. This is all the derivation of this one. So the work done is equal to MRT. It's T1 or T2. Who can answer? Is this a T1 or T2? It will be either T1 or T2 because T1 is equal to T2 and it's equal to T, 10 constant temperature. So MRT, but the volume V2 over V1 will give you the change in the work. So like this, we can say work is equal to MRT ln, that's ln of what? V2 over V1. Or we can say MART ln P1 over P2. It is the same. It's two equations. Now, what is the heat transfer? Heat transfer is basically equal to W work done plus the internal change in internal. Since we don't have any change in internal, so the work done is equal to W. And what is the W? Here's the W. So here's the W. Q is equal to W. So here's Q equal to W. Okay, is that clear? We will come back to solve equations, problems on these states. So I just want to make a brief description and then go back to solve the equation, the questions on it. Now, there is another case. The case here, it's called adiabatic process. Now, what was the third one? Isothermal. And the fourth one will be adiabatic. This is when we say PV is, that's isothermal. We change this one. So PV is equal to constant. This is the temperature constant. PV is constant. The fourth process is called adiabatic process. Remember, this was like this. The equation of this one is PV is equal to constant. Adiabatic conditions, we have to, if you want to recognize which process is adiabatic, there's two conditions to have. There is no heat exchange transfer. That's the first rule to have an adiabatic process. The second thing that is we need to know is we have PV is constant, but not like the previous one. Previous one, we say PV and pressure times the volume is a constant. Here, PV is a constant, but the volume should be to power gamma, a coefficient. This is a coefficient. We have a coefficient, a number that we have. It's between 0 to 1. Now, that is the difference between adiabatic and the isothermal. Isothermal, the volume here is power to 1, while the volume here is power to something called gamma. So PV over gamma. So the equation, or here's P, here's V. So the equation of this curve, we say PV power gamma is constant. That's the change, the difference between adiabatic process and isothermal. And plus, we don't have any heat transfer. Heat transfer means what? Means Q. So Q here is equal to 0. While here, we don't have W is equal to 0. Work done is equal to 0. While look at this one. For the third one, we said, delta U, sorry. For the isothermal, delta U is 0. For the adiabatic, what will be equal to 0? The Q equal to 0. So the Q is equal to 0. And what is the delta U? Delta U is the work done. The work done is equal to the work. If this is 0, so delta work done is equal to minus delta U, right? And what is the delta U? Delta U is equal to M mass times T sub V times T2 minus T1. Okay. And remember, here we have the CV with a coefficient of is equal to R divided by gamma minus 1. What is the gamma? The gamma is this gamma. Okay. And what will be the work done is equal to MR. Instead of CV, we have to use T1 minus T2 over gamma minus 1. And what is the Q? Q already equal to 0 because it's adiabatic. There is no heat change, heat transfer. What inside is stay inside, what's outside, temperature will stay outside between those two processes. Okay, so that was adiabatic process. Now, the last process is called polytropic process. Polytropic process is like adiabatic, but with having a small difference between them. The 5-part or the 5-state 5 of this one, polytropic polytropic process. What is the polytropic process? Exactly, it is like adiabatic, but with a change. When in adiabatic there is no heat change, Q equal to 0. Here we don't have heat change. We have Q is not equal to 0. That's the change between polytropic and the adiabatic. Now, but here what is constant? This is P, pressure V is constant, but what P is to power N. To differentiate between this state and this state, we will call this power as N, and here we will call it as a gamma. So here is the P, and here is the V, and the equation of this one is PV power N equal to constant. So there will be change in temperature, there will be change in pressure, there will be change in volume. Those will be varied from state to another state. And it's following a rule, which is PV power N is constant. That's called polytropic. And what is the equation of those polytropic status? Here's the polystate. PV is equal to power N is constant, and it's from 0 to infinity. That N, which is the index, it's called polytropic index. So this will be between 0 to infinity. So everything will be valid. PVT, PVT, they will be valid, but they will be equal in the what? In this one. Okay. Now, that's the equations that we have. That's all for equations of the state. The delta U, we have delta U because we have temperature and change in temperature for both states. We have a change of enthalpy because we have the change in also in those temperatures. We have the work, yes, we have the work. The work is equal to what is equal to the area of this. This is the area of this one, and the area is equal to the integration of what? If I have V, P delta V, P pressure, that will be the pressure, that will be delta V. The area, when you need to find the area, you have to multiply this distance by this distance. So we have to multiply P by delta V. And we have the P V power N is equal to constant. So P equal to constant over Vn. So we will substitute over here, constant over Vn times dV is the work. Now this is stay constant. So what will be the integration of V power N over dV? And it is have been integrated for you and it's ready for use. Here's the integration. Here's the rule. The work done is equal to 1 over 1 minus N P2 V2 minus P1 Q. So you don't need to memorize this one. It's already have been integrated and ready to be used, this equation. So you can use this one, you can use this one, you can use this one. That's for work done. Okay? Is that clear?
All clear.
Yes,
Okay.
doctor.
all
Please.
clear.
Yes, sir.
So this is a summary of the states. We have done with 2 examples, right? We have done with the example 1 and those 2 examples. Maybe in the next class, we can solve all will be tutorial. We will go with those equations, with those problem solutions, which are related for all those 5 states. So the problems will be telling you, for example, what is that you have to define which process is that you have, which process you are in. When you are decided the process, everything will be clear to you. You have to find, those are the variable T, P, V, temperature, pressure, volume, work done, and Q. So, sorry, and M, mass, constant, CP. So all these are usually it will be either some of them will be given to you, some of them that you will be asked to find them based on the related equation on them. Okay. Any question?